How is everybody today? And I thank everybody for joining us. All right, so we are at 9 o'clock and we're going to get started on time, just so we don't keep anybody longer in case they have things they have to get to. I'm going to turn off people's microphones and cameras, but when it's time for Q&A, please feel free to turn those back on and ask questions, and you can also put those in the chat. With that, I'm going to turn it over to Jennifer Clemens from Create, who's going to do our introduction today. And once again, just thank you all for joining us.
Good morning, everyone. So this morning we have a innovation talk. I'm happy to share that Miss Dr. Vidya Schalk is going to be presenting today on solar energy cam, shining a light on solar energy. And this is going to be about some of the lessons she learned attending some of our Create workshops in the past. So before we get started, just a couple reminders. If you aren't already on the Create Energy newsletter, please be sure to go to our website, createenergy.org, and sign up to the newsletter over here on the right. And a lot of the resources that Dr. Schalk is going to be sharing today that she utilized are here under our educator resources. And these are all Creative Commons open resources that you can take, copy, steal, edit, do whatever you want with them. So it's really kind of a baseline for any educator to use some of our solar and energy lessons. Additionally, I want to put a couple announcements out there. Right now, the Create Energy Center is starting our work for our next proposal. So this is going to be our request. You're probably going to get it a couple times in an email. Gabby's going to put it in the chat right now. But we really want to hear from educators and industry professionals about where they see the future of energy going. So as we're drafting the next grant, we want to make sure we're meeting the needs of our workforce, our educators, and our industry professionals. So please take a few minutes to complete that survey. Again, Gabby's going to put it in the chat, and you probably got it. A lot of you probably, if you're already on the newsletters, you've already got it in your email. We have a lot of events coming up. So this is one of our innovation webinars, and we have a lot more coming up. The next one is mid-April on From Wind to Watts, and you'll be getting emails on those. April 24th, we have a innovation talk on sunshine in a jar, and we have a few more in May, and I'm not going to read all those. Finally, it is time to register for Create workshops. So I know before we got started, we were talking about it a little bit, but there are a lot of Create workshops happening virtually and in person this summer. So I know on the website they say the dates, I think, are March 15th, but they're going to stay open until they're totally full. So if you are interested in one of these workshops, there is a virtual solar workshop starting April 11th. There is a workshop out at Heartland Community College on energy systems and e-rides. That's going to be June 2nd through the 4th. In North Carolina, the North Carolina STEM Educator Energy Workshop is June 23rd to the 25th. And Madison area technical colleges has two different workshops in July. One is our Standard Solar Institute. And at the end of July, they have their Solar Plus Storage Institute. So if you are interested in any of them, please take a chance to apply. Even if it says the deadline is passed, if it's open on the website, that means there's still a couple seats, or you could possibly get on the wait list. And all of these workshops, you will be getting not only a stipend, but you will be getting a box of stuff to hopefully use in your classrooms. And finally, I want to mention the Kid Win virtual workshops. These are really interesting. And again, they are highly discounted for educators, but you also get a box of stuff that hopefully you can use in your classroom. And the next one is Marine and Hydropower 101 on April 11th. So today I'd like to introduce our presenter, Dr. Vidya Schalk, and her presentation today, and I don't have the title here. Sorry. She's going to talk about her solar camps. Dr. Schalk is a faculty member at Cal Poly and he currently teaches the Sustainable Energy course, Energy for a Sustainable Society, in the Bioresources and Agricultural Engineering Department. This is an upper level undergraduate course that brings together students from more than 20 different disciplines across the university to explore the technical, environmental, and societal aspects of energy systems and sustainability. Her interdisciplinary teaching background also includes courses in materials engineering and chemistry and biochemistry, reflecting a career built around connecting science and engineering to a real-world sustainability challenge. Dr. Schalk was also honored to serve as Cal Poly's first sustainability faculty fellow, where she worked to help bring sustainability concepts across the university curriculum and encourage interdisciplinary approaches to sustainability education. Beyond the classroom, Dr. Schalk applies sustainable energy and sustainable agriculture principles in a real world settings through her work on a farm, vineyard, and winery, where she integrates practical approaches to energy use, resource management, and agricultural sustainability. As part of her summer teaching, Dr. Schalk has developed a solar energy module developed from her undergrad curriculum. She teaches this module to middle and high school students through the EPIC, Engineering Possibilities in College summer camp at Cal Poly, a program she has been involved for the past 5 years. The module is structured as a compact 4-day course, 2 hours per day with 2 different class sessions each day, designed to introduce students to the fundamentals of solar energy. The program combines lectures with hands-on activities so students can understand both the theory and practical application of solar technologies. Working both individually and in teams, students actively engage in building, testing, and analyzing solar energy systems embodied Cal Poly's Learn by Doing philosophy. Dr. Schalk has also greatly benefited from participating in the CREATE workshops on solar energy, as well as solar energy plus storage, which have helped inform, enhance the content and activities of both her undergrad teaching and her outreach programs. This webinar will present the core content from the 4-day module and demonstrate how the material can be incorporated into a school curriculum as comprehensive solar energy learning unit during the academic year or for summer camps. So I thank you, Dr. Schalk.
Thank you.
I'm going to stop sharing so you can.
Okay. Okay, I'm going to go ahead and share now. Okay, so good morning, everybody. I'm going to get started. And I hope you can hear me. If you don't, let me know. I think you can. I'm going to get started now. Oops. Okay, here we go. So I just wanted to mention right in the beginning that I got a bunch of slides and content. If anybody wants, you can email me and I will send it along, or I can send it to Gabby and she can post it. So that's available. My 4-day camp course, I'm going to call it a module. It's called Shining a Light on Solar Energy. That's what it's been called. So it's a 4-day interactive energy camp designed for middle and high school students. So this particular session, this webinar today will give you an overview of the camp's model, kind of what I teach, and also the hands-on activities, which is along with the guided discovery and how students explore the concepts of solar energy. And so like Jennifer mentioned, so it's 2 hours per day for 4 days, Monday through Thursday usually. And you can also hold 2 different sessions per day. So 2 in the morning and I'm sorry, 1 in the morning, 1 in the afternoon. So our timings are 9 to 11 and 1 to 3. So once again, that works out really well. So I've been doing that for the past 5 years and it's worked out really well. Okay, so back to what I do. Jennifer already mentioned this. I'm a faculty in the Bray department, and this is a class, it's an upper level GE class. And the fun part is I have students from more than 20 different disciplines, and several of them are non-STEM majors, like from anywhere from English, political science, history, etc. And it's really nice to have students from non-STEM majors because I think policy making in the future will be done by these students, and for them to understand the science behind sustainable energy is really important. So yeah, we welcome them, and I make sure that they completely understand all the topics. So this particular solar module was developed and delivered based on my undergrad class. So it's adapted downwards, meaning the science is rigorous and the applications are real, and it's not simplified for the sake of accessibility. So it is just as rigorous as what I teach my undergrad students. In addition, the vineyard and the winery context, so we have here what's called a field innovation hub, where we also practice sustainable energy principles in my daily life. And irrigation, pumping, refrigeration, fermentation systems, all of them rely on kind of trying to make everything sustainable. So it's in practice too. So I truly believe in that. So let's move on to what this program is about. So it's for 4 weeks in June, July, and it's called the Epic Engineering Possibilities in College. So, and Cal Poly has a whole bunch of engineering departments, so the students go to all different classes, different camps. But you can see on this slide here the cost. So this is, I believe, last year's cost. Or maybe this year, it's pretty substantial, and quite a few students get scholarships or funded through different agencies. But if any university wants to adopt it, it is a good template. So, and it's a residential program, so you can see all the different things that they do. And then the last day on Friday, they have this big event. They build a raft and they have lots of fun. So it's a full day event. They do lectures in the evening, or have people come and talk. But during the daytime, we do classes like what I'm going to show you about today. Okay, so the overall learning objectives. So at the end of 4 days, this is quite a bit of learning objectives, but you can see that it's pretty simplified. Define energy, distinguish the 6 primary forms, and I'm going to kind of literally run through the slides when I go through each day, and you can see how I put the slides together. Classification of energy, and the students know all this. It's just a matter of asking questions and getting it out of them. So it's kind of really fun, and the young students are super engaged with that. And then we move on to the PV panels and talk about photons, doped silicon, PN junction, very briefly. And I kind of intersperse a nice video in there so they can get the whole concept visually. And then we do some worksheets, go and measure voltage, current, things like that. And then we build a solar water pump, which is really, really fun, especially in hot summer days. It's really, they absolutely love it. So I'll show you some images from that. And then the final day, we build a solar cooker and they cook s'mores on it. And so it kind of takes the real world application, and I'll talk to you how I introduced that particular part. So, but it brings into play the solar energy using both the as a photovoltaic, the visible light, and the thermal part, the infrared part of the solar band. Both are being used, and so I cover both of those in this module. Okay, so yeah, so let's go with the day-by-day breakdown. This is usually my introductory slide, and I have student assistants. I should mention that. I have 2 student assistants who help me with the classes, which is really, really nice. And I also encourage them to go and, kind of take their students around, teach them, things like that. So they really enjoy it. And one of my students who joined in his second year at Cal Poly is now joined the master's program, and he wants to do his PhD and become a teacher, become a faculty instructor in a university. So it's been a really wonderful progress for him, and he started with this program. Okay, so day 1, these are the learning objectives. Just the basic fundamentals, energy fundamentals. And the theme is what's energy? Why does it matter? So it's broken down into about 40 minutes of lecture discussion, and I do a tour on the first day, we walk around, look at all the different things that the department does, senior projects, things like that. So it's kind of a fun thing for the students to walk around, look at we're not a research institute, but there are projects that the undergrad students do, so we go look at that. So this is the little more detailed breakdown of the topics. The last part is the tour of the facility, which can be incorporated in any college, university, or in a high school or anywhere. You can walk and take a look, see what's happening. These are the classroom expectations, and I used to have it in bullet form. So yesterday I threw it into Claude and Claude made the slide for me. So thank you, Claude. So I'm kind of working towards integrating AI into teaching. So, and we've done a few workshops on that. So it's kind of fun to be able to use some of those things. So I make sure that the students have it's really important that they don't hurt themselves. Safety is super important, and just general expectations so they can have fun. So I'm going to kind of zip through this, and I know it's quite a bit of slides. It's a slide pool, and it's available to pick and choose. So I'm just going to literally go through it. I'm not going to go through the contents. So we do the introduction, and these are fun questions that my student assistants picked out. And so it's really nice icebreaker kind of thing. We have the students introduce themselves and like what two things you want to pick and talk about. And it's really fun. That's the first day they get together in the university too. So it's kind of nice for them to have that icebreaker first thing in the morning. And then I go over the tentative plan and I tell them this is what we're going to do. And I have a demo of all the little things that we're going to do. I have the panels, I have the little fountain, and I have all the different materials that they're going to be using. So it's a nice introduction to them. And then I show them images from the previous year. So these are all the images of the previous year classes. So and I tell them we're going to be doing all these things, and they're like, oh, cool. They get pretty excited. These are students working on one of the solar oven. So they get a little piece of cardboard, they get the little kit in that Ziploc bag. It's all my student assistants pack it, and then we do a refill pretty much every day. We look at it and make sure everything is in it, and then the students sit outside, and it's beautiful summer day, so there's nice shade there, so they sit anywhere they want. Here are more students working away, and then there is one that's built with a template. That's a really nice one, and then they put aluminum foil on that, and then they get their s'mores done, and that's a grand finale. So they eat their s'mores and they're done with the camp, and then they go on to catch their buses home and stuff. So it's really fun, and some of the students take it back with them. Some of them recycle, so it's really up to them what they want to do with it. And so the very first year we did, my students actually were all into it. My student assistants, I should say, and they cooked all the stuff. And you can imagine cooking rice is not easy, and they managed to cook rice. And they set it up in the morning, and by afternoon class, this was all ready. And the potatoes were really excellent, got cooked, and then rice, and then the s'mores. You can see the s'mores, and those take a very little time. So it's, we got to kind of keep an eye on them. And then one of the camp counselors, and so they have 2 camp counselors per group. He brought along his Subway sandwich, so he warmed it up in the solar oven. So that was kind of fun for the students to watch that too. So this is kind of what they do on the last day. So then I tell them it's going to be really fun. You're going to learn a lot about solar energy, and then the topics for the first day, I give that just to them in a very much more simplified way, and then we go over energy basics. So I love this slide because in every single class I've taught, whether it's materials engineering or chemistry or my energy class, this really, I think, is really a very powerful slide. It tells you that the entire universe is made of only 2 things, energy and matter. And matter, most students know from their middle school, high school, solid, liquid, gas. and energy is a new concept that they're going to be learning. And then I asked them, there's energy and mass are linked, and there was a famous person who linked them, who's a person, and some students know, some don't. And then what the famous equation is, and by then most students realize what it is, and of course it's E equals mc square. And then so I talk about it briefly, but it's a really powerful concept, telling you the speed of light when it's squared, and with a very tiny mass, you can get a lot of energy. But I don't go into detail, but this is a nice setup for the students to realize that energy and matter are connected. Okay, and then we talk about different forms of energy and energy conversions, and then ask the students what's energy, and we come to that definition. And forms of energy, sources of energy, classification. Once again, I do this as a think, pair, share kind of activity. So what are the different forms of energy So think about it and talk to your partner. And then I put it on the whiteboard. And they're fantastic. From the middle school, high school, they all come up with it. It's actually my undergrads who are like more hesitant, because they don't realize, it's not a trick question. It's a really simple, it's the forms of energy. But the undergrads always think every question is a trick question. So they don't usually answer as willingly as the younger students. So the whole class comes up with this. So we talk about the 6 basic forms, and it's kind of important for them to realize that what they are. And then I go through that in more detail, just one slide per each. And so I'm just going to zip through this. So you can see what it is, different forms, and, a few minutes per each, I explain to them what it is. And then my favorite thing is nuclear energy, and we have a fantastic Diablo Canyon nuclear power plant. I take my energy class students to visit the nuclear power plant for every quarter. So it is really fun. I mean, their whole mindset is totally changed after visiting the nuclear power plant. If you guys come here, let me know. I will arrange a visit for you guys. It's really fun to visit the nuclear power plant there, and it's absolutely gorgeous, the setting where it is. Anyway, that was my plug-in for nuclear. And then we move on to the fact that nuclear energy is also, the sun gets this energy by nuclear energy, which is fusion. And then we move on to the sun as a source of radiant energy, and energy in both the light form and the heat form. And show them different examples. And just very introductory. So this is, I talk about it more later. And then the different forms of energy, that's a summary slide. And then sources. Then once again, it's a think, pair, share. What are the different sources? And then I kind of give them an example so it gets them started, like firewood, it's a chemical energy. And then they come up with all the rest of the stuff. So it's really cool. They talk within themselves, and then they will come up with that. Geothermal is a bit hard. Not many students know about it, but we get to all this. So these are all the different sources of energy, and then they get to classify into renewable and non-renewable forms. And once again, they come up with the definition, and then I put up the slide for that. And then they classify it based on what it is. And then we have this slide, and usually they're spot on, and all of them are pretty good about that. Talk a little bit about fossil fuels, because that's really important for them to understand why it's called fossil fuel. So I go through this particular slide of what is a fossil fuel, why it's called a fossil fuel, and then this I use for my undergrad students quite a bit, and it kind of, I know the younger students probably don't understand, but because I do many other modules with my undergrad students, this is the pretty basic principle. It doesn't matter what form of energy you have, except for maybe a couple like hydro or something. The process is the same. Whatever you heat the water, you get gets to steam, from steam to turbines to electricity through the generator, then go to the transformer. So this basic setup is pretty much works with most of the fossil fuel systems and nuclear and things like that too. But solar works a little differently. So we talk about that. And then this is a good video for them to, this is about fossil fuels. It's a little 3-minute video. It's kind of fun. Okay, and then this is kind of the summary for what they have done that particular day. And then very briefly talk about the law of conservation of energy. And they get pretty thrilled that this is the first law of thermodynamics. It's the same thing, but it kind of, they think it's pretty cool. Then, and what the principle, it cannot be destroyed or created, and it can be converted from one form to the other. And then I show them this particular example. This is kind of what we'll be doing. And then there are other different conversions. And then this is once again a think, pair, share question of doing what the different energy transformations can be. And then I go through this little slide set, like they get to answer what's the input form, output form, so shows them what's the conversion. And I'm just going to zip through this. So the different things, and this kind of sets their total understanding of what the energy conversion is. And then I talk about the fact that we'll be talking more about the solar energy for the next 4 days. So that's the focus. And then we do a tour of the facilities. So we go to the different machine shops, research equipment, senior projects. This was our instructional coordinator for the shops. He took them around and showed them all kinds of pretty cool things that the students do. We have a tractor pull contest and showed them all the different kinds of tractors. And this is my student assistant, and she led the group because she had some project going there, and it was really fun for her to show it to the students. This was my other learning assistant. He's the one who is going to do his graduate school and was super interested in becoming a teacher in the future. So if you do not have the way to conduct any kind of a tour, these are the alternate activities. And I've done this in my undergrad classes in the past, and they're fantastic because I pull them up, many of them from the teaching materials from the Create website. By the Numbers is great. There's a really excellent slide set that Scott has put together, and I print out a few charts, or I just put it online so the students can do that. And then I use the slide set for them to answer the question, and it's online. They're graded, and I have them work as groups, which is also really fun for them. And then the energy fundamentals, they can walk around and do an kind of an audit, very simple one, to see what different how commercial how buildings use energy. So those are all different options that are available. So that takes us to day 2. Day 2, this is we do the solar panel lab. So I kind of have to teach them about solar panels. So we start with the electromagnetic spectrum, talk about photons, talk about solar irradiance, and then they go out and then they do the calculation. We do a quick example in class, how to calculate power, and then that sets them up, how to use a multimeter, all those things. So this is all pre-activity lecture part, and then they go out and do the activity. So it's about 40 minutes or so. So my whole time period is 2 hours, and 60 minutes or more is what they get to do as a hands-on activity. So that works out really well. This is a detailed breakdown of all the topics, and and a lot of it is they do understand it, so which is kind of really cool. So you kind of have to teach it to their understanding level, but then this is the lab part where it really sets it in for them. So that's kind of what we do in the lab, to go outside and use it, and I have a worksheet that goes with it. Topics kind of breakdown for the students. We talk about solar energy fun facts, and this is, of course, if anybody has taught solar energy, this is fantastic slide for them to realize the potential of solar energy. So a great start for teaching them about harnessing the solar energy. Electromagnetic spectrum, I love this. This is like one of my super favorite slides. Or I should say super favorite topics to teach, about the electromagnetic spectrum and the fact that the visible spectrum is a really tiny sliver. And then all the different uses of the electromagnetic spectrum. The spectroscopy is a big field, and how different parts of the spectrum are used for different things, and they really enjoy that part. I kind of introduce them to wavelength and frequency, not that it's important for them, but it's kind of fun to do that. But this is the important part where we talk about the fact that in all the electromagnetic spectrum, only two parts are harvestable, so to speak, from solar energy. Visible light, it's about 44%, and infrared, 52%, and we use both of them for our activities. Ultraviolet is 4%, not so much used. It's filtered by the ozone, so not to be, we don't use that as part of the solar spectrum. And then move on to the two technologies. Photovoltaic, which is what we do on day 2, day 3, and then the solar thermal is what we do on day 4. And here's the introduction to photons, more about the photons, what the photons are, and the fact that, the color, photons, energy, all those are related. Then that goes on to the PV panels, what it means, photons, photo, light, voltaic, electricity, and that's what we call the PV panels. Most students know the common name solar panels, and we talk about the fact that it's also called a photovoltaic panel. Photoelectric effect, it's very simply, the electrons are knocked off and then they start moving, and then movement of electrons is electricity. And oops, let's duplicate it. And then the fact which materials, all materials don't do that. Silicon does that. So introduction to silicon. And once again, the periodic table, which is always fun. I love the periodic table. So it's really nice way for them to, if they've not seen the periodic table before, or introduce them, very simply, and have them find silicon and what silicon is, what semiconductors are, very briefly. And this is a slide, I believe, from one of the CREATE workshops. So it tells you silicon. For my undergrads, I talk a little bit more about the 3-5 combinations, but not for the high school students. And how silicon works, and then briefly about doping. I mean, this is all I talk about doping, and they get it pretty well. Then type P-type, and how just it moves from the N to the P, and that movement of electrons there is what creates electricity. Super simple way to show it to them. And then what the solar panel is made of. So I do a show and tell, pull out the solar panel and show them the different parts and what it's in layers, and silicon, that layer is really thin down there, and what else it's made of, and then how it's organized into a cell module panel array. So, and students from California have seen these arrays. Would they drive through the solar farms? Practically all students live or have seen a solar panel. This is a really fantastic video. This is by Energy 101 by the Department of Energy from a long time ago. Fantastic videos out there for anybody who teaches any energy modules. So this is one of those. And then I also show them this TED Talk, which is 5 minutes or so, which shows them the whole NP junction and how the holes and the electrons move. It's really cool, this one. So that takes them to electricity. We'll talk briefly about solar irradiance, introduce them to watts per meter square because they have to use a digital meter. So good introduction there. And what it is, it's instantaneous power per unit area. That's the instrument they use. And once again, this is from CREATE, from the equipment grant that I got a bunch. So I use them for my class. A really fantastic resource. And then I don't call this a Lambert cosine law, but you should know, I don't. I just talk about it conceptually, and I use a flashlight demonstration for that. So I do a demo at this point, turn the lights off and do a flashlight demo about the diffused light. And then they do a think, pair, share, talking about, this is a prompt for them. Every location on Earth receives sunlight at least part of the year. The amount of solar radiation that reaches any one spot depends on what are the different things. And they come up with answers, and it's pretty good. So we go through the whole thing, time of day or night, movement of the sun, seasons, atmospheric conditions, geographical location, local weather, local landscape, things like that. I mean, I kind of pull this together, so I then break it down, talk to them about each one. And yeah, they enjoy that. And then the sun's rays, how they're, how it angles. The sun's lower on the horizon during the winter months, and then about the solar window, plus minus 3 from noon. All those things. Once again, this helps to talk about the angles, weather conditions, how that impacts, and students get all this. I mean, they actually come up with this. Trees, buildings, all those impede your panels, the positioning, all those things. Then I show them this. That's, by the way, the Mojave Desert solar panels where they're used. And then we look at the global, US, local, and this is a really nice irradiation chart. And this is to show how much sunshine is available around the world. And then this is a really fun one because this kind of shows the annual solar distribution. And then we look at an area like, San Francisco, San Jose, and go along the same latitude to Washington, D.C., and we go, even though it's on the same latitude, what's the difference? So then the students come up with the fact that, it's cloudy, more rains, not so much sun, whereas in the western part of the United States, I'm sorry, yeah, so California, Arizona, we got lots and lots of sunshine. So even though we're on the same latitude, you can see how much more sun we have here because of the climatic conditions. And then also it gives them an introduction to the metrics that you can measure all this. And that's why we use that meter. This is for our local San Luis Obispo. Then I introduce them to this, the fact that the geometry matters, how you put the panel, and then they do this as their part of their worksheet. They go outside and do this. So then they go out. I didn't put it here, but I walk them through the multimeter. I'll show that in a different slide. Anyway, so they go do, I probably shouldn't have this here. This is a solar panel lab. So they go out. This is a worksheet that they work with, and I go through all these. I'll show these slides. Kind of it's got a bit rearranged itself. So they have small panels. So they do large panel, small panel. Then they do number of panels, 2 panels, 4 panels, or 1 panel. And then they go through the light source, whether it's room lights inside the room or a phone flashlight or a bright lamp. I have one of those big LED lamps, or they go outside. So then they do use their multimeter to take the readings, and they use the little pyranometer. I guess it's not really, it's a solar meter to take the irradiance, watts per meter square. And then they do a group discussion, and then we do a class discussion at the end to go over this. They're able to do this pretty easily. It's not that complicated, and so it works out pretty well. They love worksheets, so it's really fun, especially the tilting part. They have a protractor in their kit, and they figure out what the angle is, and so they can write down their different readings. We also kind of get to play with all these little things that somebody had purchased in our department, so it's kind of fun for them to run those little things with the solar cars. So I'm going to move to day 3. There's parts here that I use on day 2, and sometimes I flip day 3 and day 2 depending on the weather conditions, and you'll see why. Because it really depends on, because for this particular class, I think we do need a little bit more solar energy. So if it's a little cloudy on day 2, or if I see the weather forecast, I can shuffle it around. So here is where we talk about the fact that solar energy does real physical work, and you can measure it. So and once again, it's broken down into lecture and lab. And these are the learning objectives. Talk about DC, AC current, and just electricity in general, and then how electricity travels, the whole grid part, and then do a demo to show that you can use solar panels for in real life. So this is once again the breakdown. Start with the think per share. Unfortunately, I somehow must have missed the slides where I talked about the voltage, current, and all that. Anyway, so I do all that. So voltage, current, this was done the previous day. They get to use a multimeter, what's voltage, what's current, what's how to measure power, voltage times current, all those basic concepts. And then this is a good review for them because they'll be using this again. And then we talk about movement of electrons. This is all recap. And this is the stuff they had done the previous day. And then we move on to how solar panels make DC, but all the equipment at home, everything runs on AC. So how do we move from DC to AC? What happens in the what exactly is AC DC? First of all, talk about that briefly and give them different examples. And then the fact that we've got to solve this problem, and that's why we have inverters. So from panels that are like rooftop panels, you got to get into inverter to make sure it moves the current from DC to AC, which is what is usable. And so that also brings them to gives me an opportunity to talk about the whole grid, how it's set up. And then we talk about the step up, step down transformers, where you can move electricity through long distances. So, and that's something really new for the students. And my undergrad students too. They've seen all the substations, they've seen all those things, but they have never known actually what exactly it is for. So this really is really for most students, they've never heard about this. So I talk them through that, how electricity is produced and how it gets on the grid. And for my undergrad students, I actually, they go and track the whole energy system. And I didn't put it in this, but that's also another activity you can do. If you go to openinfrastructure.com, I believe that's the website. It's really, really cool. You can track literally the entire grid lines of the entire actually the whole world. Somebody has open sourced the whole thing, so you can see how electricity it is transmitted throughout the world. It's really, really cool website. So anyway, so we talk about that, how it works, and then a little bit about net metering, which is one of those controversial topics, which I don't go into great detail, but the fact that if you generate excess, it can go on the grid. And then that this is a rooftop solar panels, a small amount, but the same principle applies for the larger solar farms too, where you connect a whole bunch of panels together and you do it on a large scale. And this is utility scale, so it's by PG&E or companies like that. So they get to see the difference, where that's where a lot of our electricity comes from. Then we go on to a lab part. So you can measure it, now you use it. So that's a concept. So here, these are very simple things, very inexpensive because it's a one-time purchase, and then you can use it forever. I mean, it's really cool. Once again, the panels, thanks to Create, I got a whole bunch of panels, and then we got a few multimeters, and a lot of this we had in the Bray department, but the Create workshop you can get with the grant. And then a bucket. This is from Home Depot or Lowe's. And then the pump. It's actually a bilge pump. And I looked online yesterday. It's like $13. So it's really quite inexpensive. And then it's a matter of just connecting them all together. I showed this particular video how a pump works because a lot of students like to know how a pump works, because that was one of the things feedback we got was, we use the pump, we don't know how it works kind of thing. So I go, okay. A short video helps them quite a bit. Then this is how they connect it. This is one of the previous years. And then it goes into the bucket, and all powered by the solar panel. And they try to figure it out, how one works, how two work, connect it in series or connect it in parallel, see what happens. And then they all get to pick. Each of these tubes are 5 feet in length. So we deliberately cut it in 5-foot sections because you can go 1, 2, 3, 4, how many tubes we have. So how long a distance I can push the water through. And I also, you have them do a rate calculation. So if you see that there's a little measuring cylinder, so one of them does a timing and then they fill it up with the pump and see how fast, how much water they can get and how many solar panels you can use. And they have a worksheet that goes with it. So it's really fun. So they sit outside and one of them, it's like the tubes have holes drilled in them. So it's like a shower. And that's just with one panel. So it's pretty cool how and once again, all depends on that. That's lots of clouds up there. On days when it's clear, you can really see the whole, and it's a nice one when they see the clouds passing through and they see the effect of the clouds. Once again, it gels all those things that they talked about. And then I have them do it as a group where they all pull together and connect different panels, all the different, and then they see how far they can go with that. Yeah, they have lots of fun with that. And then this is my student assistant. He connected the little small tubes and we're kind of having fun. That's our demo unit. I have one set up as a demo unit, and then the students, each one get for their own groups. This was one of the classes. And I let them do whatever they want, however they want to join up. They go tall or they go longitudinal. So this was really fun. So the whole class joined together, connected all our panels, and then they pull it out for a very long distance. It was really fun. So each section is 5 feet, so they can measure it too. This is a worksheet that goes with it. Really fun. They do their measurement. They write down their rate flow and everything. And then they have group discussion, and then we do a quick class discussion about all these things. And then brings us to day 4, the final day, which is really lots of fun. Now we talk about the same sun, but a different technology where you can cook with it. And then these are the different learning objectives. So once again, we talk about the electromagnetic spectrum, which part of the spectrum is used for this particular activity. And then I talk in great length about solar cooking, how it works, how the whole works about that. These are the different topics. So there's 2 ways to do this. We can do the lecture part or have them watch a little video. I have the video in the end. I'll show that to you. So they can watch the video, start the build, get it all ready, put their s'mores out, and then I do the lecture. Both these things work. Once again, I look at the sun outside and see if the sun is not out yet. In the morning class, I do the lecture first. In the afternoon class, we do the activity first and then do the lecture, and either which works. So we move on to the fact that there's so much solar energy, but a lot of it, people don't know how to use it. And there's many different ways to use it. And one of the ways very few people know about is solar cooking. Solar panels, a lot of people are familiar with, but not with solar cooking. And then why do we need solar cooking? Once again, this is a think, pair, share. And then they come up with a few answers. We talk about what's the worldwide situation about people cooking inside their homes using fossil fuels or burning things, and the effect. Here's a little baby, and what is the effect of having this cooking with burning things to cook. And then the WHO statistics about 3 billion people in the world cook with biomass and coal, and 4 million people die from associated emissions every year. So for my undergrad class, we talk about this in pretty good detail with different charts and things like that. So what are the reasons for using solar cookers? And the students come up with all the answers. It's pretty cool. So it's free, renewable, health reasons, avoiding inhaling smoke, prevent deforestation. Biomass is all about, cutting down forests and things like that. This one they don't come up with. This one I introduced the fact that, most cultures, there's the women who go collect firewood and they go for miles and miles, exposing them to all kinds of dangers. Then I briefly talk about the fact that you can use solar energy for safe drinking water. And United Nations actually has a little kit where they have a little wax thing that you can, and it's a ready-made kit. And you don't need to get to 100 degrees. It's safe drinking water even at 70 plus degrees, 70-ish. So, and then the wax starts to kind of melt at that temperature, and then they know it's ready. They can drink that. One of these days, I do plan to get that kit. And then the fact that lack of electricity or any reliable source of cooking is really, really a critical need. And that brings the whole concept of food insecurity, where, if you don't have a means to cook, you can have all the food you want, but if you can't cook, you don't have the resources to cook, it's going to have a lot of issues. And then you have all this rural to urban migration, and then social factors, all those things. And students a lot of times come up with that. Then I introduce them to real life situations like this, and show them what and most students recognize these are like refugee camps and things like that. Once again, here's another refugee camp where you see there's nothing, literally, these are tents with nothing around, no electricity, no resources. And this is, this really, shows that importance that every minute, and this was many years ago, I would say like 22 data. It's even worse now. 24 people leave everything behind to escape war, prosecution, or terror. So, and all these refugee camps around the world, we have a lot more now. The concentration of all these and the millions of people living in all these camps. And then we talk about how we can use solar cooking in real world, and that's cooking with light. And talk about the concept, literally how it works, how the energy is trapped in the car example works really well. Then once again, which part of the electromagnetic spectrum is used? In this case, we're using the infrared spectrum. And this is a concept, kind of like the car or a greenhouse. It create, and then we talk the different components of cooking with light, which is concentrating the light, for which we need the angle, has to be focused. And then the absorption, a dark surface, and students come up with that. Retention, how do you retain it? By putting blankets or plastic bags or something, some kind of an insulation. So 3 basic principles. So very simple, they all get it. 3 main designs, the box type, the parabolic type, and the panel. The top one is a panel, and that's the one we designed. So I show them examples of box types. And a lot of schools do this with a pizza box and things like that. And I found the panels a lot easier. This is box types, parabolic kind. I show them a bunch of slides how you can use parabolic kinds, the physics behind it, how you focus the light beam, and the fact that it's pretty concentrated, and you can actually fry steaks and things like that if you get it in the right angle. And then the panel type. And panel type has many different designs here. This is actually this particular, I believe it's solar cookers. I ordered a kit from them, and that's how it looks like. So I have that as a demo unit. And it's really cool. And I paid $85 for it. So we go, okay, that cost $85, but we can make it for $5. So they get pretty jazzed about that. Though $85 was a donation, I should mention, because the solar cooker company, it's not a company, it's a nonprofit organization, works with the United Nations to drop those off in the refugee zones. So it's a donation. If anybody wants to order it, it works as a great demo unit. Different kinds of panels, so you're not limited to just using one model. You can use many different kinds. And then I tell them about this university faculty in one of the universities on the East Coast. She actually collects all the solar cookers and studies them, and she's got a really cool YouTube video that she goes through all this stuff. It's pretty cool. Other kinds, like the evacuated vacuum tube, it costs, I think, I don't know, $400 on Amazon, but these kinds are available, more a gourmet kind of cooking deal. And then we come with what we're going to be working with. And this is called the modified CooKit. CooKit was the original one. It was developed by a bunch of engineers. The modified version is what we use because it's a lot simplified, and we can do this, and students can do this in 30 minutes or so. So it looks really complex, but once they get into it, it's super simple. We use yardsticks and small rulers. Each get a piece of cardboard like I showed you. So the cardboard I just ordered from Amazon, exact measurement. And the cool thing with this particular template is I just need to cut 3 strips of aluminum foil. So I go to Costco, buy the aluminum foil, and I cut it into 3 strips. It's 32 inches. So I put a mark on the table with 2 tapes, and I just cut it out and have it all ready to go. So it makes it easy for them. Otherwise, aluminum foil is a is a really messy proposition. So I highly suggest having it ready made to go. So they just come and pick up their pieces one at a time, and then they put glue on it and they put it in 3 strips. And then all this has to be pre-done, all the folds. So it's a really nice practice for them to work, measure all this, use their protractors, and they get pretty good at it. And my student's assistant helped, the counselors help. So, and then they cut out the slots there. So those heavy bands are the slots. This is what they get in the kit. And I tell them right from the beginning, this is a real life simulation. You get only 1 piece of cardboard. You only get 3 pieces of foil. You get only 2 sticks of glue, no tapes, no clips. Follow the instructions, which is really important as future engineers. And then more importantly, problem solve, and then recycle all your material when you're done. So it's really fun. And then I have them watch this little video. It is a video done by a 4th grader, and I go, you can do it, you can do it. So it's really fun. This is a really cool video. So this really, it's very detailed. I'm really astonished this little kid did this really fantastic video. If you guys get a chance, watch that. It's really cool. And then they either take it home or recycle it. These are students working on it. As you can see, these are high school students. That's their little kit. And they can work on tables, or they can go work on the floor, on the outside, anywhere they want to. The long rulers, over years we have collected a lot, but they can share that too. The small rulers, they all get one. So classroom, or they can go outside like we saw these students working here. It's really fun. And it's an individual thing. So they all work individually. They put their aluminum foil, and then they set it up, and then we can do the lecture part, or they can chat and have fun or whatever. It's pretty fun. So one of the years we did a modification. Actually, Rudy was here, my husband. He set up an Arduino system, so they could actually take temperature measurements every 2 seconds. It would record that. And then we took it inside to the computer lab, and then they pulled down all the data on the computer, pull it into an Excel, and charted the temperature. So it took a little longer time. But that was fun. So that's also another, if you have an extra day or something, you can do that too, an Arduino project to go with the whole thing. So yeah, this is all of them with their little solar after they ate their s'mores. Yeah, different things that we cooked over time. Same slides from before. And then
awesome. Can we move on to questions?
Yeah.
It sounds like you have a
Well,
lot of
I'm
stuff
done
here.
So that's it. So you're right on time. And I put together the summary slides and all that. And I think I'm just going to go through this anyway. So this is what we have. You can replicate all this. I'm sure you have questions about this. So I kind of anticipated some of the questions. Module works because you can pick and choose. And then the different resources, and then how you can rotate it out. And you don't need great labs or anything. Anybody can do this. Cost breakdown. I got all the cost breakdowns there. And in my case, I had several things from the Create lab, which worked out really well. Once again, there are different cost breakdowns, but once again, it's a one-time thing. S'mores, I buy packets from Costco. And so if you distribute the cost, it works out to about $3 to $5, $6. And these students already pay for the whole camp. So their allocation. This is all, I should say, I just send the receipts to the things for the consumables, and it's pretty minimal. So it's pretty cool. Okay, so questions.
So we had some questions in the chat. Some people were asking for some resources,
Yeah.
and I know Gabby can
Okay.
connect you all, but does anybody want to unmute and ask any questions?
Yeah, I do. So Vidya, excellent presentation. Love it. It's a great idea. My questions are going to be your logistics. So, do all the students, first of all, during the camp, do they reside on campus in lodging, or is this a commuter camp?
It is lodging, so they stay on site for the whole week.
And then they have food privileges from like a dining hall and things like that?
Yes, yeah. So it's a full day camp for them. They stay there for, I believe, 4 days. And yeah, Thursday afternoon they leave. So it's like a full activity for them all week long.
So did you have to have extra students helping out to be like counselors or had to be chaperones
Yes.
to get
So
that through?
yeah, so the sizes of the classes, or I should say each team, so they have lavender team, orange team, or whatever team, they have their own t-shirts, their own mascot and everything. They're with each other for the entire week, I should say, or the 4 days. They have two camp counselors per group, and then I have two lab assistants for the entire week.
Terrific. Did you have any sponsorship from any energy companies to help support this, or is this all supported by the students' registration fee?
Students registration mostly, and the EPIC program gets a bunch of sponsorship. So
Terrific.
they subsidize for students who cannot afford it. So a whole bunch of, so one year they brought a whole bunch of middle school students. They were all on scholarship. So it was really nice to see, the fact that they were all supported by different foundations and things like that. The way they do the allocation, I don't require the full amount, but I believe each student they allocate about $30 to $40 for lab equipment, consumables, and things like that. That comes from
Very
the
good.
tuition and from the EPIC funds.
Excellent. Thank you.
Mhm.
We had a question in the chat about what's the maximum number of students that you have in your sessions?
I would say I've had about 22. Yeah, 22 is a good number. Anywhere from 18 to 22 is what I've had. So not more than that. I don't think they make their classes that big because they have to be with each other all day and they're taken around campus. So I think the counselors can't handle more than that. So yeah.
And I have a question. I know this is a hard age to recruit for. I know you can get younger ones pretty easy, but that middle school, high school that are interested in science and engineering is challenging. Do you
Uh,
do any part of that recruiting, or does your institution set that up?
yeah, the institution sets it up and they have a waiting list actually.
Oh, wow. That's a
Yeah.
good problem to have.
Yeah, it's
Wow, that's
and
awesome.
they have expanded it over the years. I know, and during COVID, they actually did it virtual. Even there, they had a lot of students on, so they sent them the kits home. I didn't do that at that time, and they didn't have the solar one at that time. I started the solar one when they came back, but a lot of people were doing it online. So it's a very, I would say, popular program and word of mouth again, students hear about it, and we get students from all over California, and we get from out of state too. And a lot of students who come to visit their grandparents and things, they all sign up, and there's like clusters coming from the Bay Area. I mean, there's so many high schools. We have students from so many different high schools.
Any other questions?
This is just Gabby here, and I just wanted to say that Vidya, I will get with you to get the resources that have been requested and send them out to everybody. And then I just wanted
Okay.
to thank you today for your presentation. It was very informative, and I really appreciated it. It was great.
Yeah, thank you. I probably went into too much detail, but it kind of gives you a flavor of, you really don't need to dumb it down. I do the exact same things for my undergrad students, and it works for middle and high school students. So
Yeah, I love the excuse me, the activity where you had the students just extend the pipe out as
Oh
far
yeah.
as they could to see. Normally we
Uh-huh.
just do something short, but then to see,
Yeah.
again, and then discover how much more power
Yeah.
is needed. Did you have any issues with the pumps operating if you went ahead and, just kept putting on more modules, maybe to increase the power? Did you have any negative effects on the pumps?
Not really. No,
Okay.
the only thing that would happen was somebody invariably would slack, and then it would one part of the pipe would collapse.
Ah,
but but
well,
I mean, and we also went up 20-25 feet, and for my undergrads we do a contest on how high you can go. So I think
terrific.
22 or 25 was a record at one point,
Ah,
so that works out pretty well, fun too. I discourage them
that's
from
awesome.
going up tall, because then it's a safety issue. uh,
Right.
but yeah, going parallel to the ground works out really well.
Yeah, very good.
Pam says you took
25
solar
feet is a lot
fountain.
ahead. That's impressive. If your students are getting them that high.
Yeah, you're going to need bump hats and safety glasses then.
Yeah, right.
Yeah. Pam says you took solar fountains to a whole new level.
Oh, thank you.
Absolutely.
Yeah, yeah. It's yeah. The pump. I mean, for $13 of pump, and
Yeah.
the just those little tubes, PVC tubes, it is a really fun activity.
Did you just use wire nuts to connect the wires from the modules to your pumps, or did you have any connectors on there?
No, I got alligator clips.
Okay,
Yeah,
great.
and that's all they needed. So alligator clips on both ends, and they just work pretty well.
Very nice.
Yeah.
Well, thank you all for participating. Your enthusiasm for the material was amazing. So thank you so much, Dr. Schalk.
Thank
And
you.
stay tuned for our next innovation talk on April 14th. Thank you all for participating.
Thank you. Thank you.
Thank
And
you,
Thanks,
everyone.
you're
Vidya.
most welcome to,
Yeah.
I had my email on one of the slides, or you can email me or send an email to anybody, and I'm happy to share all the slides. You're most welcome to use it.
Thank you, Vidya. Appreciate it. Say hi to Peter for me.
I will.
Thank you.
Thanks. Yeah.
Bye,
Yeah.
folks.
Bye. Bye.